Hello guys, my name is Ravi Angwar and you are watching Engineering Thermodynamics Studio. In my previous lecture, I briefly discussed about the performance parameters of refrigeration. Now in this lecture, I'll be teaching the types of refrigeration system. They are vapor compression refrigeration system, vapor absorption refrigeration system, steam jet refrigeration or vacuum refrigeration system and air refrigeration system. So in this lecture I'll be only teaching this above two refrigeration system. So let us understand the first type of refrigeration system, that is vapor compression refrigeration system. It is a mechanical type of refrigeration system which employs four essential components: evaporator, compressor, condenser and expansion valve. In this type of system, we use that kind of liquid refrigerant which can absorb enormous amount of heat so that it can evaporate and condenses easily or readily. So this vapor compression system is a closed system because once the system is charged with the refrigerant in the system, it will never come out of the system until unless it is a major leakage or major defect in the pipeline. This system works on a vapor compression refrigeration cycle. The most widely used refrigeration cycle is vapor compression refrigeration cycle. Now I'll explain this cycle with the help of the diagram shown below. So this is a refrigeration cycle with showing all the components: evaporator, compressor, condenser, expansion valve. So your refrigeration cycle is shown graphically on this TS diagram. Your y-axis represents your temperature, your x-axis represents your entropy. Now 4 to 1 is evaporator, 1 to 2 is your compressor, 2 to 3 is your condenser, 3 to 4 is your expansion valve. Now I'll tell you the function of each component. 4 to 1 is evaporator, in which a liquid refrigerant will absorb the latent heat of vaporization from the product or space. Now 1 to 2 is your compressor. In compressor, work input is given to the compressor so that your compressor can run and increase the temperature and pressure of the refrigerant vapor. So at point 2, your refrigerant vapor pressure will be very high as well as the temperature. So point 2 to point 3 is your condenser, which is responsible for conversion of a refrigerant vapor into liquid refrigerant. So at point 3, your liquid refrigerant will be highly pressurized, and you cannot send highly pressurized liquid to the evaporator because evaporation will not take place. So you have to send that highly pressurized liquid to the expansion valve, which is there in 3 to 4. So this expansion valve will reduce the pressure of that liquid refrigerant. So inside the evaporator, low pressure liquid refrigerant is entering. Now I'll be telling the processes individually which is happening inside the components. So 4 to 1 is happening your constant pressure heat addition in the evaporator. 1 to 2 is your isentropic compression. 2 to 3 is your constant pressure heat rejection, and 3 to 4 is your throttling in an expansion valve. Let us understand the second type of system, that is vapor absorption system. So in this system we use two working fluids, that are refrigerant and absorbent. The main component of this system are evaporator, absorber, generator, condenser and aqua pump. If you are using ammonia vapor absorption system, then ammonia will be your refrigerant while water will be your absorbent. The most popular absorption system is Electrolux refrigerator. Now I'll be telling the working of this vapor absorption system. So before I tell you the working of this system, you should know the flow cycle of your refrigerant and your absorbent. So first I'll be telling the flow cycle of your refrigerant. So it is from condenser to evaporator through an expansion valve, and from evaporator to absorber, and from absorber to generator with the help of this aqua pump, and from generator to your condenser. This is the flow cycle of your refrigerant. Now I'll be explaining the flow cycle of your absorbent. So it starts from absorber, goes to generator through aqua pump, and from generator to absorber through throttling valve. So this was the flow cycle of your absorbent. Now I'll be telling the working of this vapor absorption system. At the outlet of your condenser, the liquid refrigerant is highly pressurized. You cannot send that highly pressurized liquid refrigerant to the evaporator because evaporation will not take place. So you are fitting a expansion valve in between. So highly pressurized liquid refrigerant enters the expansion valve, which reduces the pressure of the liquid refrigerant. So inside the evaporator, your low pressure liquid refrigerant entering inside the evaporator. Now in evaporator, liquid refrigerant will absorb the latent heat of vaporization from the product or space which in turn gives your refrigerant vapor having low pressure and low temperature. So at the outlet your refrigerant vapor pressure is low as well as the temperature is also low. So your refrigerant vapor having low pressure is enters inside the absorber, which is absorbed by the absorbent. So a strong solution is made in the absorber, which comprises of your ammonia and water. So what happens when it is absorbing the refrigerant vapor, its pressure is reducing, so it will absorb more amount of refrigerant vapor, which results in the heat evolution, and this heat evolution will be removed by the cooling media. So at the outlet of your absorber, strong solution will be having low pressure, and this low pressure strong solution will be going to your generator with the help of this aqua pump. Now this generator having high pressure and it continuously heat is being added. Now what will happen, your refrigerant vapor having the low boiling point, it will vaporize while your water will get separated, and it will be going to absorber with the help of your throttling valve. Now at the outlet of the generator, your refrigerant vapor will be highly pressurized, and again it will be going to the condenser, again it will condense, and the same cycle will go on. TB stands for throttling valve and EV stands for expansion valve. With this, I finish this two refrigerant system, and next your air refrigerant system and your vacuum refrigerant system I'll be covering in the next class. Thank you so much.